Hey, what's going on, guys? It's Mr. Sanchez coming at you with another lesson for section 4.5, part 2. We're going to do two more examples in which we graph some more rational functions. And then our third example is going to be what do we do when they give us the graph and tell us to find the function? Okay, pretty easy. All right, so back to the hard stuff. Yeah, I know this is a long section. Last video, 20-some minutes. I'm sorry, guys. But let's go over this. All right, we're just gonna go straight into the problem. The same process as usual. Step one is to write our degree, our function in factor form, right? So this has 3x, that has 3x. We can factor out 3x from the top, and we're left with x minus 1 on the top. With on the bottom, we can factor this into x plus 3. Oh, my bad. This is a this should be a 12, guys. This starting off wrong. Wrote down the problem wrong. This should be a 12. So instead of having a 3, we're gonna do x minus x plus 4 and x minus 3. I'm so sorry. Yeah, that problem was written wrong. So that's step one done. What's our domain? Our domain is x such that x cannot equal 4 -4 and x cannot equal 3. Right? So that's our domain. Right? Step two is to write in lowest terms. It's already in lowest terms. Don't worry, the next example we'll probably have to go over that part. It's in lowest terms. And next up, we gotta do what? What do we gotta do next, guys? What do we gotta do next? Next up, we gotta find the intercepts. So step 3 is our x-intercept. So that's when y is equal to 0, right? So we're gonna let the numerator equal to 0. So we got 3x times x minus 1 equal to 0. So that means x is going to be equal to 0 and x equals to 1. So at 0, 0, and 1 comma 0. And because they're multiplicity 1, it touches. All right, now we're going to do our y-intercepts, right? Our y-intercept is when we let x equal to 0, right? So what happens when x equals to 0? We already know that if x equals to 0, then you get 0. So our y-intercept is 0 comma 0. Usually if you have an x-intercept at 0, that means that's also your y-intercept. All right, we're not gonna bother plugging it in. All right, step 4. What is step 4? Step 4 is finding vertical asymptotes. So our vertical asymptotes are pretty easy. Our vertical asymptotes are x equals -4 and x equals +3. All right, and they both have multiplicity of 1, which means they're going to be going in opposite directions. Step 5 is to find our horizontal asymptote or our obliques, but that's pretty easy. They have the same degree, so we're going to take the coefficient. So it's going to be y equal to 3/1, which is just 3. So our horizontal asymptote is 3. Where did I get the 3 and the 1? Right, so we just look at these two. It's a 3 and 1, and it's going to be what, 3. Step 6 is to graph, given all this information. All right. So we're going to draw our axis. That's always a good place to start. And then after that, we're going to plug in what we know. All right. So we have a vertical asymptote at -4. 1, 2, 3, 4. So vertical asymptote at x equals -4. All right, I'm gonna write that over here. X equals -4. And we have another vertical asymptote at 3. 1, 2, 3. All right, so at x equals 3. And we have a horizontal asymptote at y equals 3 this time as well. So 1, 2, 3. So look, we have this nice graph here. We next have to find out if we ever cross here. Do we ever cross our intercept? That's an important question. Do we ever equal to 3? So we need to find out when our graph equals to 3. Well, first let's plot some things. We know our x and y intercept, so our x-intercept is going to be at 0, 0, and 1, 0, right? What else do we know? What else do we know? 0, 0, 1, 0. We also know that we're gonna go in opposite directions, but because let me just double check something, guys, real quick. Yeah, we do go over this. We do go over this point. Yeah, just making sure. All right. Last thing, like I said, we gotta find out where we go over here. Sorry, guys, I was just looking at the solution and I got a little confused because their graph is scaled horribly, right? So we gotta find out if we ever crossed our intercept. So how do we do that, guys? We're actually gonna let the whole function equal to the 3. So we're gonna let this equal to 3, and then we're gonna solve. So you actually have to multiply the whole denominator to the other side. So we're gonna have 3x squared minus 3x equal to 3 times 3x squared. So 3x squared plus 3x minus 36, and we're gonna solve, right? We're just gonna solve over here. We're gonna do minus 3x squared. That gets rid over that, right? And then we can actually do minus 3x while we're at it. Minus 3x. And you're gonna get negative 6x is equal to negative 36. So you're gonna get x is equal to 3. Oh, nope, my bad. Divide by negative 6. And then negative, it's gonna be equal to 6. So at 6, we actually cross our y-intercept, right? So at 6, we get 3. So 1, 2, 3, 4, 5, 6. So right, we actually cross here. I know it's a weird thing, but we'll be fine. Okay. Now, since we know that we're gonna go through here, I usually try to test another point, but since we cross at both of these zeros, right? We cross here and cross here, and this is the only spot. So how to determine how to graph this, right? So we know that we cross at our intercept, right? So we got to cross here and here. So when we look at our graph, something like this, we know that our graph has to go like this. And it's not gonna go the other way. It's not gonna go like this because of our intercepts, right? Our asymptotes, right? So because of our asymptotes, we're not gonna go there. All right. Another thing we know is that our vertical asymptotes have a multiplicity of 1, right? So because our asymptotes have a multiplicity of 1, we cannot come from the same direction. So this one's gonna be kind of weird because our graph actually is gonna cross our asymptote and then go back up and then go closer to the asymptote. And then same thing over here. This one doesn't cross over here, it just goes like this. I know it's a little confusing, but that's basically our graph. Okay. Remember, these are just sketches, they're not accurate. So don't worry about all the precision of it. All right. All right, now let's go on to the next problem. The next example, right? What happens if we have this problem on our heads, right? So step one, step one is to factor the top and the bottom. You can do the X method, right? So 2 times 2 is 4. Gotta add to -5. Does anything multiply to -4 and adds up to positive 4 and -5? Yes, -4 and -1. But we gotta divide by 2, right? So that's gonna give us -2. That's gonna give us 1/2. So we know the top is gonna factor to x minus 2 times 2x minus 1. And the bottom is gonna factor to x minus 2 times x plus 2, right? Which means that our domain says x cannot equal 2, x cannot equal -2, right? Step 2, write in lowest terms. So lowest terms means we're gonna actually cancel these out, the x minus 2s, right? So r of x to be in lowest terms has to look like this. 2x minus 1 over x plus 2. Step 4. No, my bad. Step 3. The graph has one x-intercept without multiplicity. All right, so we got to find our x-intercept, right? So we got to let the top equal to 0. So 2x minus 1 equal to 0. That means x is going to be equal to 1/2. So 1/2 comma 0, that's our x-intercept. And then our y-intercept is going to be what happens when x equals to 0. So you're going to get -1 comma 2. Right? Because you're going to do 2 times 0 minus 1 over 0 plus 2, which equals -1/2. All right. All right, let's see. Because our graph is in lowest terms, now we got to find our vertical asymptote. So step 3, our vertical asymptote only occurs only when x equals to -2. Right? We have a hole at x equals +2. We got to remember that. We'll come back to that. Step 4. Oh wait, that was step. That was step 4. Step 5. We got to find the horizontal or oblique asymptote. Well, we know because when I was at its reduced, we know that our we just look at the coefficients in front of x. So our horizontal asymptote is gonna be y equals 2. Right? And now all we gotta do is graph. All right, guys. All we gotta do is graph. And let's look at my graph. All right, so let's see. We're gonna have a horizontal asymptote at y equals 2. So we're never gonna cross here. And we're gonna have a vertical asymptote at, where did I put my vertical asymptote? At x equals -2. All right. We know that our y-intercept is at 0, 1/2. We gotta use blue. And we know that our x-intercept is at 1/2, 0. Right. All right. So we know that our graph is gonna come this way, or this much, but that means that this graph is gonna go this way because this 0 has a multiplicity of 1. Right. This asymptote. So what do we got to do? So we actually got to figure out one more thing before we find out. We got to find out what happens when x equals 2. All right, so we're just going to plug it in. All right, we're going to plug in 2 to our original function. And by original function, I mean the very, very original one. And that means you're going to have 2 times 2 minus 1 over 2 plus 2. That's 4 minus 1, which is 3 over 4. So at 3/4, we're actually going to have a hole right here. That's going to be 2, 3 over 4. And we're not going to actually touch that point. We're going to just, that's a hole. And that's how we graph it. All right. We're actually just going to touch it. We're actually just going to skip that spot because that's a hole. And then the holes are tough. All right, guys, just one more example before we call it a day. I know, long lessons, but it's a hard topic. All right, so example 6, constructing a rational function from its graph. So right here we have our graph and we gotta just notice some things and then we're gonna write our function. First things first, let's look at our vertical asymptotes. I think that's the easiest way to go. All right, so remember R of x is equal to P over X over Q over X, right? The top part are zeros slash x-intercepts. The bottom determines our vertical asymptotes. All right. Okay, and then we'll use the rest to find out what we need. So let's start with our zeros, right? So let's start with our x-intercepts, okay? So we have an x-intercept right here. That's at 2, 0, right? Negative 2, 0. So that means we have x plus 2, okay? And because it touches, that means our multiplicity is 2. And right here, that's 1, 2, 3, 4. This is 5, 0. We have another 0. That's going to be x minus 5. And because it crosses, our multiplicity is going to be 1. Okay. That's our numerator. Now let's look at our vertical asymptotes. We have vertical asymptote at x equals -5, right? So that means we're going to have x plus 5 happen here. And since they're going the opposite directions, these graphs, we're going to leave it like that, all right? But you're going to notice we also have a vertical asymptote at x minus 2. But what happens at -2 is that if you look at -2, we're actually going down the same direction. So because we're heading in the same direction, we're going to actually square that. And then you think we're almost done. You're going to notice that if you look at the powers, this is 2, this is 1, 1, and 2. So right now, if we were to FOIL all this out, our function would have the same power, right? And if they have the same power, we need the coefficient, our y, to be 2, right? So we're going to let the top equal 2 over 1, right? That gives us our horizontal asymptote. And that's it, guys. That's it. That's our function. That's a fun example. This one's a little bit harder. We'll have more examples in class. That way you'll have more time to figure out how to do this. All right, it's a little hard, and I know it's a lot of topic, but we're at the end of the semester. All right, guys, have a great day. Bye-bye.